So we have been talking about financial maths for the last 2 weeks. And today we are going to go to the final part, which is timelines. But I just want to remind you, there were two major parts. There was the interest part, which was week 1, and we had compound interest and simple interest. And then in week 2, we had the loss of value, which is depreciation, and we had simple depreciation, and we had compound depreciation. But there were some fancy words for simple depreciation. So I want to ask, what is the other way to describe simple depreciation? What is the other word? You can put your hand up and tell me audibly or in the chat, what's the other word we use for simple depreciation? Who is going to tell me first? Let's have a look. What is the other word that we see in exams and tests for simple depreciation? Cullen, you nailed it. It is straight line depreciation. So sometimes instead of simple, we say straight line depreciation. Okay, what about compound depreciation? What do we sometimes say? They say something else instead of compound depreciation. Indeed, Profunzo, you're right. It is called the reducing balance depreciation, or RBD, reducing balance depreciation. And that's the same as compound depreciation. Now, if we look at the yellow and the green formulas, there's only one difference. What's the only difference? Well, if we connect up the right ones, the only difference between the formulas is that when we deal with depreciation, there's a negative, whereas when we deal with interest or appreciation, there's a positive. And then there was one more formula, which is this one, except I wrote it like this. I wrote it as the I effective is 1 plus I nom over m to the power of m minus 1. I want to know, in this formula, what are the m's all about? What are the m's about? The words say the nominal and effective annual interest rates. So this is the nominal interest rate per annum. That's the effective interest rate. What do the m's stand for? Okay, so it's basically a number that depends on the compounding time. So if you are compounding per month, m will be 12. If you are compounding per quarter, m will be 4. What this letter is doing is it's splitting up the annual interest rate into smaller chunks. And so this number is basically allowing us to compound over shorter intervals as we need to. The difference between the nominal rate is the stated rate or the base interest rate. The effective interest rate is generally going to be higher than the nominal rate, because when we split things into smaller pieces, we get interest on interest. And so the effective rate will always be higher than the nominal rate. And sometimes they give you the effective and say, what's the nominal? And sometimes they give you the nominal, and then you have to work out what the effective is. So give me a thumbs up if you at least recognize this formula from earlier lessons and you have some basic idea of what I'm talking about. Basically, whenever we do a compound interest calculation, we need to chop up the nominal rate into whatever the compounding interval was. And if it's per month, it's 12. If it's per day, it would be 365, and so on. All right, so that is the basics of financial maths. Now, we are going to talk about timelines. So what are they talking about when they talk about timelines? Well, we're talking about investments with time and interest rate changes. So things change over time, and these changes over time happen on a line. So we call it a timeline. problem. So when you think of a timeline problem, we'll often talk about the beginning being T naught, and then maybe at the end we'll have T something else. So maybe if our timeline is in months, it would be T24. Or if it was in years, maybe it could be T5. And maybe along the way, there would be a T3, which is the end of the third year if we were using years, or if we're using months, we might say something like this is T18 and this is T54. So at that point here, you've had 18 months. At that point over there, you've had 54 months. If something changes, if at a particular point in time, we give it its own little marker on the timeline. So maybe we could say something like the interest rate is 8% per annum for that period there. But then for this period over here, the interest rate is not 8% per annum anymore. It's divided into a monthly interest rate. And so then we would change the interest rate and we use the timeline to help us calculate. Now, it'll be much easier if I do an example, but give me a thumbs up if you understand the idea that on a timeline, there are important points that we have to mark off. And that between those points, things will happen. Okay, and this is T naught is the very beginning. In this case, T54 is the end. All right, let us go to question number 1. And this, ladies and gentlemen, is why I love this question, because we just follow a process. So Tabo is lucky enough to have 1,000 Rand in the bank for 10 years. What I'm going to do is I'm going to say, this is T naught and this is T10. Give me a thumbs up if that makes sense to you so far. Okay. Now, I'm going to put a plus 1,000 below T naught. That's this 1,000 Rand. That's how much money Tabo is investing. Okay, now I'm going to go through. It says the interest rate was 6.5% compounded quarterly for the first 3 years. Well, suddenly I know that something important is happening at the point of 3 years. If you read the next part of the question, okay, so it says for the next 5 years, the interest rate was calculated at that. What is going to be the next point on my timeline? That was T3. Where do you think I'm going to make a point on my timeline? What's going to be my next? Is it going to be T4, T6, T7, T8? Helen, I agree with you. It is T8. And you know why I agree with you so much? Is you took 3 and you added 5. So the first 3 years were happened. And then it said for the next 5 years, the interest rate was calculated compounded monthly. And then it says for the remainder of the investment, the interest was calculated semi-annually. And just so I get to use all my colors, the interest rate was initially that. So these are the important points in time at which the interest rate changes. Again, give me a thumbs up if so far you are with me on the bus. You haven't fallen off the bus or the taxi, you are with me. Okay, fantastic. Now, here's the next bit. I really love these questions. Can you tell? The interest rate was 6.5% compounded quarterly. So I'm going to put here, I'm going to put a little squiggly line to remind me that there was an interest rate. And my interest rate is going to be 0.065. But I have to do something to it. What do you think I have to do to my 0.065? Who is going to take the prize? Pop your hand in the air, wave it around like you just don't care if you want to answer, or put it in the chat. Helen, you're on the money. Divide by 4. And the reason we divide by 4 is it said compounded quarterly. Now, how many quarters are there in a year? There are 4. So if we take that interest rate and we divide it into 4 pieces, we get that. Okay, now, when we go between here and here, the interest rate is different. It is going to be I is equal to, in fact, you know what? The I is not even necessary. You guys, well, maybe I should write the I. Okay, what the heck? 0.072. What am I going to divide that by? What am I going to divide that by? Well, it says monthly, and that is a yearly interest rate. So we'll divide by 12. Well done, Atlekang and Provenzo. You're on it. Okay, now, last bit here. I is equal to, for the remainder of the investment, the interest was 7.8 compounded semi-annually. Okay, I know from the beginning of this chapter, I know that to get 7.8, I've just divided it by 100, right? That's where I'm getting this from. But I have to divide it by something else. What do we divide that by? Semi-annual means twice a year or half years. So I divide my interest rate by 2. Okay. Ladies and gentlemen, you have drawn a beautiful timeline. Now all you need to do is apply some formula. How much money would Thabo get at the end of the investment? Now, the growth formula that we are going to use for this is going to be A is equal to P1 plus I to the power of N, because this is compound interest problem. Give me a thumbs up if you understand why we have to use that formula. Okay. I've lost some of you. Now, here's what it says. It says here, Thabo invested 1,000 Rand in a bank for 10 years. The interest rate, he is getting interest on his money, and we are compounding the interest. That's why we need to use the compound interest formula. So let me show you how this works. If I take this formula, which I will put over here, I want to know how much money do I have at the end of this first bit. So I'm going to go, it's 1,000. But now I need to put an interest rate in there for this time period. I'm going to choose to put the interest rate 0.065 divided by 4. Give me a thumbs up if you understand why I'm choosing to put the green interest rate for this first period on the timeline. Because I wanted to grow from here all the way to there with that interest rate. Now, here's the problem. My interest rate is in quarters, but I have 3 years here. What is the number going to be in the block up here? Because remember, the interest rate needs to be per quarter, or the number of time periods needs to be quarters. So you've got 3 years, but I don't want years, I want quarters. So it's just going to be 3 times 4, or we can just say 12 to save ourselves. Maybe I should put it as a black number just so it doesn't get confusing. So that's because there's 3 years here, and you basically say just times by that number. Now, the problem we have is we need to know how much Thabo has at the end here. And we've only got to the green cross there. We need to make our way all the way to there. So what I'm going to do is I'm going to pretend this bit is my p-value, and I'm going to allow it to go with this next part. What am I going to put here for my interest rate? Because remember, this thing over here is just the input value for the formula. It's just this thing here. So that thing there is just this whole thing here. That is the p-value. And I'm trying to go from here to here. What interest rate am I going to put there? Well, because I've left this part of town, I'm going here. I'm going to go 0.072 over 12. but I've got a problem. How many years does it take to go from a green cross to a blue cross? Well, from T3 to T8 is 5 years, but the problem is I want it to be in months. So because this is a monthly interest rate, so what should this figure up here be? Yeah, it's going to be 60 because 5 years times 12. Okay, quick score out of 10. How are you guys feeling so far? Where this is unhappy face, this is okay face, this is happy, happy face. 0, 5, 10. Where are you guys on the scale so far? Let me know in the chat how you're feeling so far about this example. Don't worry, we're going to go very slowly. We're doing 2 lessons on this. So if you're feeling overwhelmed, don't stress. All right, now the problem is for Tabor, we need to get to the end of the timeline. So we need to get to here. So I'm going to pretend this whole thing is just the p-value, and I'm going to open up another bracket. So this whole thing is the p-value, and I'm going to go 1 plus. What is my interest rate going to be here? Well, it's just going to be the interest rate above there. What is the number over here going to be that I need to grow it for? What is the number over here that I need to grow it for? So in the land of years, it's 2 years, but that doesn't match what my interest rate is. What is, it's going to be, well, it's 2 years, but it's half year. So there's 4 half years in 2 years. Or you go 2 times the number there, that's going to be 4. All right, so what does this whole rather scary looking thing mean? This is the 1,000 Rand that Tabor was lucky enough to start with. This is the growth for the first 3 years. Then that keeps growing for another 5 years, and then it grows for 2 more years at the end. Now, you need to get an answer for me with your calculator, but everyone, this gets a bit tricky. So what I would suggest is when you type it in your calculator, why don't you press equals at that point and then go times, put in that part here and go equals again, times this part at the end, just so that you don't have to type for too long. And you tell me what you get, how much money has Tabor actually got at the end. So take out your calculator. It's time to be a calculator warrior. And remember what I said, rather press equals at this point and then go on and then go times the next part equals, just so you don't have to type so many things all at once. Students often, if they try and type this whole thing in, oh my goodness, they just get lost and stuck and bad things happen. So I'll give you some time and then you put your answer in the chat when you are done. And you have done your first timeline question then. And I want to see some agreement in the chat before I reveal anything. Tabor started life with 1,000 Rand, lucky Tabor. And how much extra money has it got to by the end of all of this? Can anybody confirm? Oh, there we go. Atlachang has got your back, Pufunzo. There we go. Anybody else get? We are getting 2024.64 rands. Anybody else got that? Can you give us? Renew is with us. Well, let's see what I got last year when I did this. I got 2024.64. So the good news is we are winning at life. Now, obviously, you can take a screenshot here if you want, or you can look at the recording later. We need to practice this. But the basic idea of setting out your timeline, putting the amount that's growing at the bottom and going through the different time periods is one that I really want to emphasize. And students who do this, they get this problem fairly easily. Okay, now, I want you to take this question and I want you to build your own timeline. Don't do the whole question. Just make your own timeline. And when you are done drawing your timeline, just put a T in the chat. So you draw your own timeline using the technique that I showed in the previous example. What would your timeline look like? Welcome to Unjabulo, Onalena, and Sapang, Tandiwe, Pusisiwa, Sunday. I think I have welcomed everyone else. If I've missed you, I apologize. But I'm so impressed that you're here and you're working hard. Okay. So put a T in the chat when you have done with your timeline. Okay, so that's T4. Now, where is something for the first year? And then, okay, so what I'm going to say is that my timeline has T0, T1, and T4. And then for the first year, now this is interest is 0.11, and it's also SI. So I'm just going to say SI just in case I forget that that's the case. And then over here, then the interest rate is 0.125 divided by 4. I think that's the important information. You could put CI, but basically CI is the most common one. So we don't say CI for compound interest. Give me a thumbs up if that made sense to you. Okay, now, there are two types of interest that are being used, two different formulas that are being used. Can you see if you can get me to how much money the amount of 5,500 grows to by the end of T4? But you have to realize there are two different formulas at play. I just want to give you a chance to do this one. You may not get it right, but just give it a crack and see if you can get an answer for this. And I will help you a little bit. I'll say, look, you're starting. Let me move these formulas to the other side. You give it a go. You tell me what you think you're going to get. I will. So we have plus 5,500, and that has to grow to there. But then something else has to happen. I have to grow from there all the way to there. What numbers are you guys and girls going to get for me? Give it a go. And the question is, determine the value of the investment at the end of 4 years. I get this bit for the first part, but I still need to figure out what goes here to get me to the end. And you're going to tell me in the chat what you get. If you are stuck, don't be afraid to ask a question. I do love a good question. I love to hear a student voice. Or you can use the chat. But how much are we ending up with at the end of all this? So 0.125 over 4, but it can't be 3 here. It's 3 years, but I want it in quarters, so it's 3 times the number there. So this is going to be 12. And I'm even going to do this with my calculator as well. I'm going to go 5,500 times, open bracket, 1 plus 0.11 times 1, close bracket, equals, and I get a number, then I go times, open bracket, 1 plus fraction, 0.125 over 4, close bracket, to the power of 12, and I'm getting 8831.88. And Callan and Pufunzo agree with me. Anybody else agree with me? Fantastic. So what I want to say is that you can see, even though timelines have a lot of information, if you know how to set them out systematically, boy, are you going to gobble up these marks when it comes to finance. And life will be very happy when you do these questions. All right, time for a break. I need your brain to just have a moment to zoom out for a second. And so let us stand to our feet. You know the drill. We are going to do some jumping jacks and all sorts of other things just to breathe. So let's do this. Okay, start with some deep breaths just to relax. So breathe in. Breathe in. One more deep breath. Oh, feels so good. Feels so nice and relaxed. Okay, let's shake it out a bit. Shake out the arms, get them nice and loose. Get all that tension out your body. Shake out this arm. Shake out the leg. Give it a shake, shake. All right, and maybe even a little twist like this, but just gently, not too much. Oh, I can hear clicks. Okay, just roll the shoulders back a little bit. Okay. Now, to really get our brains thinking about something completely different, we need our heart rate to jump a little bit. And the best way I know of doing this while still facing the camera is a jumping jack. However, I'm open to alternative suggestions if you can think of something. But for today, let's do 15 of these jumping jacks. In 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I'm feeling them today. My knees. Oh, I don't know what is happening there, but how are you feeling after the jumping jack experience? Let me know with an emoticon how Bunzo looks like the jumping jacks have made an impact. Sunday says, tough day at the office. So many tears. Don't you guys do phys ed at school? Or some PT? Didn't they make you run a little bit? Okay. Let's get going. So here is your next question. This one you're going to fly more solo by yourself. It says 14,000 is invested in an account. The account earns interest at 9% per annum compounded semi-annually for the first 18 months, and thereafter 7.5% per annum compounded monthly. How much money will there be in the account 5 years after the initial deposit? This is straight out of a past exam. You just give me a T for timeline when you've done your timeline, and then I'll check that your timeline makes sense, and then you'll do the final answer after that. So everybody get a pen, do your timeline, and then this question will become easy. And then also, if you need some extra guidance, just pop a question in the chat and I will help you where I can. Okay, there's two ways of doing this. I'm going to say 18 months is the same as T1.5 because I'm going to stay in years. It's not wrong to do months here, but then that would also have to be months. And most of us think in years. So I would have gone with T1.5. And then for this bit, I would have gone I is 0.09 divided by 2. And then for this bit, I would have gone I is 0.075 divided by 12. Now, these are both compound interest problems. So the only formula you're going to use is this. Get me my final answer, please. Oh, let me not forget how much money was invested. There's a plus 14,000 at the bottom. That's how much. So you have to grow to there, and then you have to grow to get there. So I want to know. And then pop your answer in the chat. So this is actually going to be a 3 because it's saying, look, it's going to be 1.5 times 2. That's the way to get 3. Or to think about it is, how many half years are there in 1.5 years? There's 3 half years. Now that's for the first bit. But now what about for the next bit? Now what's this number going to be? I might even need my calculator because it's 3.5. So I'm going to go 3.5 times 12, and I get 42. Because there's 42 months in 3.5 years. Now, how much is that going to be equal to? Well, I think I'm going to need a calculator myself. So you put your answer in the chat while I do my calculating. Okay. I get 2755.08 Rand. Did anybody else get that? See, just check if anybody else got that. So if you messed it up, try again. So 14,000 times open bracket 1 plus fraction 0.09 divided by 2 close brackets to the power of 3, and then I'm going to go equals. And then I'm going to go times. So now I'm going to do the green bit. 1 plus fraction 0.075 over 12, close bracket, to the power of 42 equals 20755.08. Give me a thumbs up if you got that. Thumbs down if you didn't. Just so I can get a feel for students in the room. Thank you, Reniwe. Anyone else? Can I have some? Onalena, thank you, Pafunzo, Tandiwa. Okay, Callan, just have a look at the process. It might be that you're keying it into your calculator wrong. So have a look at that. Also, remember there's a recording and you can go over this example again. Okay, now, here is an interesting one. I want you to read this and tell me what is different about this example. So take a moment to read it, and then I want you to say in the chat, what is different to the other examples we've done so far? What do we think is different? Okay, so Callan has said she deposited more money, or there is more than one deposit. Yes, that's exactly it. So there's multiple deposits. So we need a way of taking our beautiful timeline and dealing with multiple deposits. Okay, before we even worry about that, can you please draw a timeline for this question? And once you are done, I want you to put T for timeline in the chat. So I want you to draw me a beautiful timeline. Think about points along the way and see what you would do. What do you think the important points in time are going to be? Yeah. So Reniwe, you quite don't worry, Reniwe, you're going to see in just 2 minutes how beautiful mathematics is, because it's if you lay it out properly, you're going to see this is not that hard. It just feels cluttered, and so you need some mathematical thinking to help you. We will get there, I promise. Okay, I think T0 and T7 are definitely the beginning and end, but I want you to put some more points on the timeline and then give me a T in the chat when you feel like you've had a proper crack. Okay, so I'm even going to put plus 5,500 because 5 years later. Okay, well, 5 years later must be T5. Okay, well, I'll deal with that in a moment. I'll come back to that. Interest for the first 3 years. Oh, okay, so the first 3 years, T3. Thereafter, it changed to something else. Okay. Now, what I'm going to say is that T0, T3, and T7 are important, but T5 is also important because at T5, something happened there. Give me a thumbs up if you're okay with my timeline so far. All right, now we have to deal with this interest thing. So what interest for the first 3 years? Okay, so I'm going to draw a nice squiggly line to do interest. What is interest? Here, it's 0.14 divided by 2. So interest for the first 3 years was 14% per annum compounded semi-annually divided by 2. Thereafter, the interest rate changed. Thereafter, it changed to 12% per annum, but compounded monthly. Okay, thumbs up if you're with me so far. Thumbs down if I've lost anyone. Now, you may say, hold on. You have just ignored T5. Why is T5 not getting any attention? Well, here is the clever thing that I love about this question. When did the 4,000 Rand come on the scene? It didn't arrive at T0. It arrived in line with T5. So I'm going to put plus 4,000 over here. So what has to happen to the money? This 5,500 has to grow to the end of 7 years, whereas this 4,000 only has to grow for 2 years. What is the formula for growth? The formula is going to be that formula. Okay, so how are we going to do this? Well, I want to suggest that this grows to that point like that. And then from there, it grows all the way to there. Whereas this part over here, it just has to grow that little bit here. And so the way we're going to do this is we are going to treat it as 2 separate pieces. So you are going to have 5,500 and it's going to have its journey. And then you're going to have a plus 4,000 and it's going to have its own journey. Give me a thumbs up if you can follow my basic idea of what I'm proposing. The fact that the 5,500, okay, I'll tell you what, I'm probably losing. Let's do this. So what did I, this was 4,000, huh? Let's grow, let's do this. I'm going to take my 5,500 and I want to grow it for 3 years. So it is going to be 1 plus 0.14 over 2. What is the number up here going to be? Because remember, 5,500 has to grow for 3 years, but the interest rate is not in years. What's this number here going to be? Well, it's 3 years, but it's half-year interest rates. So it's 3 times 2, which is 6. So that's going to be 6. Okay, but now I've only grown to here. I have to grow for 4 more years. So I'm going to pretend this is my initial input. And I'm going to go 1 plus 0.12 over 12. What is the number at the end here going to be? So again, let's look. Even if you get stuck, you can always use your highlighter. You have to go from here to here. That is 4 years. But I look here, that's a 12. I want it in months. So 4 times 12 is 48. Okay, so the 5,500 has reached the end of its journey. It gets to whatever that is. But there was another amount that had to grow. And this was the 4,000. So it gets its own little plus. What is the interest rate that I'm going to put inside here? What is the interest rate that the 4,000 is going to grow at? If we look at the timeline, what color seems to go above the 4,000? I think it's 2 years, because remember it's in line with T5, but it's in months. It must be 0 point, let me use the blue because that will be helpful, 0.12 over 12, and then this is 2 years, but in months, so that is 24. So just to show you what's going on here, the 5,500 had to go through a green journey and a blue journey. The 4,000 only had to go through a little piece of the blue journey. I want you to try and use your calculator to key this in and get me an answer. But here's your tip. After you've keyed in this bit, press equals, then get the next bit, then go equals, plus, and then do that. Otherwise, if you try and round and carry and write down, oh, you're going to be here till next week. So see what you can get for me as an answer. And then you've done quite a hard question. So I'm going to have to do this also. So let me go 5,500 times, open bracket, 1 plus fraction, 0.14 over 2, close bracket, to the power of 6. And I'm just going to bring it down, go equals, I've got a messy number, times, open bracket, 1 plus fraction, 0.12, over 12, close bracket, to the power of 48, equals, plus 4,000 times, open bracket, 1 plus fraction, 0.12 over 12, close bracket, to the power of 24. And I get, I get 18. I'll check my answer in a moment, but I get 18,386.28. Now, did I make a mistake? No, there we go. This is the, oh, sorry. That is the fancy, but I think that I like my squiggly way better. So that's the answer, but I think I prefer my squiggly things. I feel like they're clearer. So I get 18,386 Rand and 28 cents for my answer. Are there any questions? I'm sure there must be some students who have some questions because it does look a bit fancy. But what I like is look at how the number here starts at the beginning, but this one starts here and we have them on separate lines. Think how clever that is. And look at how the key points all have visual explanations. I feel like that's a really clever way of dealing with this question. Give me a score out of 10. I mean, these are properly difficult questions. We'll have another lesson on this. But how are you feeling on the 0 to 10 score scale about timeline questions over there? How are you feeling? Okay, now, for those of you who are feeling a bit overwhelmed, remember the recording will be out fairly shortly, and you can simply go over this. And the more you do it, the easier it will get. Okay, so it's not like you should be 100% ninja today. You can get better by practicing. And that's why you're here. This was the first time you're trying to do this. Should I find you another question? Just do one more before we finish today. I feel like I can squeeze in one more. Let me go find you one from last year. Is that, have a look. Let's go look at this one. Okay, here is, okay, let's do 4.2, and then we finished for today. So we are going to do Zakele's question. So the one in yellow is, and I want you to start by drawing your timeline. And when you've drawn your timeline, let me know. So put T for timeline when you've done your timeline. Okay, let's see what we would get here. T naught, T8, T4. Now, what else do you think the timeline needs still? Okay, so let's do this last bit. Interest rate for the first 4 years is 0.084. Half yearly is divided by 2, and then rises to I is 0.092 divided by 12. And what is the formula? The formula is still the compound growth formula, but it says how much interest. So when they say interest, when you get your final value, you need to work out how much of it is interest if you compare it to the original. So get me my answer. How much interest has been made on this 10,000? I'll wait for you to put the answer in the chat, and then we will declare the lesson over for today. So this bit over here is 4 years, but it's in half years. And so 8 is the right number, whereas this is in months. It's 4 years in months, is 48 months. That's fine. Okay, now here's the thing. I do need to know what the final value is, but then I need to also subtract that 10,000. 10,000 times 1 plus fraction 0.084 over 2, close bracket, to the power of 8. And I'm going to go equals, so times, open bracket, 1 plus fraction 0.092 over 12, close bracket, to the power of 48, equals, now at this point in time, I'm going to have that much, but it said how much interest did I make? And since I started with 10,000, the amount of interest is just going to be that minus 10,000, which is 10,051 and 76 cents. Right. That is today's lesson on timelines. What are the main ideas that I focused on? When you're given a rather text-heavy question, remember that drawing a timeline is the most important part. Put the important points in time in on the thing first, then put the interest rates on the timeline, and if there are amounts of money or even different amounts of money, put them below. Then let them grow using the compound interest formula or any formula that is relevant, and in the end you'll get to your answer like this.